I'm Anil Kumar. Welcome to my series on trigonometry. We'll talk about radian measurements in this particular video. Treat this as part 1. We are going to have 3-part series. In part 2, we'll have application questions based on radian measurements. And in part 3, we'll have few test multiple choice questions. Let us now understand all about circles, sectors, and segments. So here we have a circle which defines all these terms. So let's see and identify all these terms from the given circle. Now based on what we are doing now, we'll have 7 questions here, correct? You can actually pause the video, answer these questions, and then look into my suggestions. Now whenever we talk about a circle, 2 things define a circle. One is the center, the other thing is the radius. So here the center is at O, radius is R. Now I have made 2 points on the circumference A and B, and these 2 radii will form a triangle kind of thing like here, right? So this will help us to define many of the terms. So the angle here is the angle theta, and opposite this angle we see an arc AB. So this circular path along the circumference is called the arc. Now at times we also call this as the minor arc, the smaller one. The other part is also an arc, and we'll treat that as a major arc, the bigger one. Okay, so that is also an arc, a bigger one, major arc. Now here what you see is a slice of a pie. Now this is called sector. Chord is the line joining A and B. The longest chord could be diameter, right? So the longest chord could be passing through the center, and that will be treated as diameter. So diameter is also a chord. So the end points of a chord will lie on the periphery of the circle. So that is how I could identify it. There is a small area in between. This area is called the segment. So these are a few technical terms which we are going to use in our 3-part series. There are some formulas which will be of interest. One of them is to convert degrees to radians, and what we know is 360 degrees is equal to 2 pi, and that could also be written as 180 degrees is equal to pi. So that is the conversion factor. A equals to r theta is another very important relation to remember, which I'll prefer to make a triangle and then share with you. So in this triangle, think like distance, speed, time. So the distance A, r and theta, right? So A, the arc length, is equals to r times theta. Now from here, you can always write what theta is. So you can write theta is equal to A over r. Now this particular relation, theta is ratio of A over r, gives you answer for what 1 radian is. This is when we are doing measurements in radians, right? So in this particular case, when we write like this, we are assuming angle theta in radians. And that makes it important to understand that most of the time when we are solving problems related to circle, we are working with theta in radians. You can work in degrees also, but working in radians is simpler. That is all, right? So that is kind of key thing to remember. Okay, now let's get back to our questions one by one. I hope you must have got answers for most of them by now, right? Okay, so question number 1 is to convert 120 degrees into radians. How do we do it? That's the formula. But how do I remember? Let me share that with you. We are saying 120 degrees, right? I want radians. So I'll multiply by pi, which is in radians, and divide by 180 degrees. So degree and degree will cancel and you will get your result in radians, right? So that is the whole idea. So it really helps to kind of understand how we could easily do these calculations. Now that is cancelled and you can divide by 6. So if you do that, 6 times 2 and 6 times 3, so we get this as equal to, let me write here itself, 2 over 3 pi. So 120 degrees is 2/3 of a pi. Pi is like half, right? Half the circle. 2 pi is full circle. Question number 2, define radian. So here we see that theta equals to A over R, right? So 1 radian could be what? So radian basically is a ratio of arc length to radius, right? So that's a very important definition. So radian basically is a ratio. We can say ratio of arc length to I wrote radius, so let me not write this line, to radius of any circle. Right? So that ratio is the angle subtended at the center of the circle, right? So radian is the angle. I should write 1 radian is ratio of arc length to radius, and this is basically the angle which is subtended at the center of the circle by that arc, correct? Now the second part of this question is convert 1 radian to degrees. Now 1 radian basically means that A equals to R will give you 1 radian, right? We are saying when A is equal to R. So if I assume R to be length 1 unit, in that case for a full circle the circumference will be 2 pi, correct? So for a full circle the circumference will be 2 pi. Now let me write here and show you what 1 radian is equal to, right? So what we can define here as 1 radian is basically equal to 360 degrees. Now convert 1 radian to degrees, that is the question, right? So 1 radian is basically ratio of 360 degrees to 2 pi, where the angle subtended theta for a full circle in degrees is 360 degrees and in radians is 2 pi. So this particular ratio is 1 radian. So let's calculate this ratio. So it is 360 divided by 2 times, let me divide by 2 first and then I'll divide this by pi. In decimals it is 57.29. So you can approximate this as 57.3 degrees. It is a good number to remember, right? So 1 radian is basically equal to 57.3 degrees. You should remember, since radian is the ratio of 2 lengths, it really doesn't have any unit of its own. Perfect? Question 3. Find arc length if r equals to 5 and theta equals to pi by 6. So we're given theta in radians. So whenever we use pi in this kind of scenario and we do not write degrees, it is assumed to be radians. So radians is the default unit when you are working with circles. Remember that. So the arc length formula we know is A equals to r theta, So you can find arc length A as equal to product of these two. So it is 5 pi by 6. Simple as that. So that is the length, and you can just write units. It is, as you see, basically it will have same units as that of the radius. Perfect. Question 4. Find major arc length if r equals to 10 and angle theta is 110 degrees. Now in this particular case, major arc length means that which is with bigger angle, correct? So one option could be you could find what the bigger angle is and then find, correct? Now these types of questions we could easily solve by ratios, right? So the arc length basically is the ratio of the angle to the total angle, right? So normally, let me define here, theta by 2 pi is basically equal to arc length by 2 pi r. Since 2 pi r is the whole circumference, right? The periphery of the circle. So that is the relation which actually relates arc length with the radius, right? So as you can see from here, we can actually cancel 2 pi and 2 pi, and we get a relation arc length A as equal to r theta. Now this is only possible when theta in radians. So that is how we derive our relation. Perfect. So one option for you could be you convert this angle to radians and then figure it out, or what you could do is you could use 2 pi r and find the ratio with the angles. Total angle is 360. So I will use a method where the conversion is not required. Is that okay? So let me show you how to find solution of this. So if 110 is your minor arc, for major arc, let me call that angle to be phi, will be 360 degrees minus 110 degrees, correct? So when you take this away, you get 0, 5 and 2. So it is 250 degrees. Think like this. That side angle is 250 degrees. So the major arc length will be ratio of 2 pi r. So let's do it here in a different ink. Okay, so let me show you this solution. There's less space. I should have done it on a new page. We'll do it here. Okay. So the major arc length A major is equal to 2 pi r. So 2 pi times the radius given to us, which is 10, times the angle, which is, that is the whole circle, right? Angle 250 degrees divided by total angle of 360 degrees. So that ratio gives you the arc length. So in basically working with circles and radian measurements, we are always working with these kinds of ratios. Let's calculate our answer. So we have 250 divided by 360, and we are going to multiply this by 20 pi, right? The answer in decimals is equal to 43.6. Correct? And the units will be units of radius. So that is how you could actually find the major arc length. So you can find 2 pi r, which is the circumference, and then the ratio to the angle over 360 to find this answer. So I hope that is clear. Okay, let's take question number 5, 6 and 7 on a fresh page. I hope by now you have learned all the concepts and you're ready to answer these questions. Let's also take a small break and then solve question number 5, 6 and 7. I hope you enjoyed the nature. Now let's get back to our classroom setting and answer question number 5, 6 and 7. So I'll take up question number 5 and 6 on this page and then we'll continue with question number 7. Question 5. What is the sector area if theta equals to 60 degrees and r equals to 2? So as you know, sector is this area. We are given radius as 2 and the angle theta as 60 degrees. So the sector area basically is the ratio of total area, which is pi r square, times the angle. Now since the angle is given in degrees, we'll keep the angle in degrees and divide by full circle angle of 360 degrees. Does it make sense to you? Perfect. So that is how you could do it. So we have pi, r is 2, so 2 square, times angle is 60 degrees, divided by 360 degrees. So that is how we are going to find the answer. Let's calculate this. So 60 divided by 360 is 6, as you know. So we have 4 over 6 or 2 over 3 pi as the exact value. You could also calculate this. So you do 60 divided by 360 times 4 or 2 square times pi, which is 2 over 3 pi, and in decimals it is approximately equals to 2.1. The units will be in terms of units of radius. In this case we are not given any units, we'll say unit square since it is area. Perfect. So that is how you could find area of a sector. Now question number 6. What is the sector area if circumference is 8 pi and theta is pi by 12? Now in this particular case, we are given the circumference. Circumference is basically equal to 2 pi r. So we are saying that this circumference is equal to 8 pi. So that should help us to find what r is, right? So r is equal to 8 pi divided by 2 pi. So the radius is 4 units. We know the radius and we need to find the sector area. So in this case, the sector area is equal to area of the circle, which is pi r square, times angle theta over, since we are talking about radians, we have to divide by 2 pi. Now see how simpler this particular formula becomes. Since we are dividing by 2 pi, the pi and pi cancel, right? So we get this area as equal to half r square theta. So that is the sector area. So it is a very important formula to remember. In our case, we can just calculate this value. Since now we know the radius is 4 and the angle is pi by 12. Correct? So we could easily find this. So the exact value will be pi by 12. You could always simplify this, 8, and dividing by 4, we get 2 over 3. So I hope you have copied the formula. Sector area equals to half r square theta. It's a very important formula which can help you to find immediate answer given angle in radians, right? So the unit square will be our units. So we can write this answer as equals to 2 by 3 pi unit square. Let's take up question number 7 now. What is the segment area if r equals to 8 and theta equals to pi by 3? So when we say segment area, we are interested in this portion. Now this requires some calculations, right? So let's redraw the whole thing slightly bigger to understand this scenario. So I'll make a bigger version of this. So it's a big triangle, chord, this is your chord, and that is the arc. Correct? We are interested in finding the segment area, which really means this portion. Correct? How do we find it? Well, let's do a bit of construction here. We'll drop a perpendicular to find the area of this triangle. We know these two sides are equal and they are equal to the radius, right? So we know these sides given to us are 8 units. And the angle given to us, this whole angle is pi by 3, which is 60 degrees, right? So since this is an isosceles triangle, this perpendicular will also divide this into equal segments, so that becomes the midpoint, right? And the angle here will now be 30 degrees. I should write pi by 6. Okay, so let me write this as pi by 6. Perfect. I hope you remember the special triangle. We're using the special triangle to find the height. So in a special triangle, the ratio of sides are 1, 2, and square root of 3. Correct? If the angles are pi by 3, pi by 6, and pi by 2. So we know this side, which is 8. So the other side has to be 4, correct? And the altitude should be 4 square root 3. Correct? Or you could use trigonometry, correct, to find the height. So use any method you like. Perfect. Now let's try to solve this question. So basically we are going to find area of the sector first. So first step is area of sector. So area of the sector, what I'm trying to say here is this big area. Correct. The formula which we just derived is half r square theta. Perfect. So it is half of, radius is 8, so 8 square, and theta is pi by 3. Right? 8 square is 62, and half of 62 is 32, or 64, and half of 64 is 32. So it's 32 over 3 pi. So that becomes the area of the sector, which is 32 over 3 times pi. Now, let's find the area of the triangle. So we'll take away from this area of the triangle, which is half base into height, right? So we know area of the triangle is half of base times height, which is half of, base is 8, right? So 4 and 4. It's kind of an equilateral triangle, right? It is 8. And the height, which is 4 times square root 3. Let's calculate this answer. Okay. We can write decimal equivalent of both, right? So half of 8 is 4. 4 times 4 is 16. Basically 16 square root 3 we want to find, correct? Which in decimals is equal to 27.7. This value in decimals, 32 times pi divided by 3 is equal to, in decimals, you can write this as 33.5. Okay. So we found this area to be 27.7. Here this area is 33.5. And so we can subtract them and find area of the segment, which is basically what we need, right? So this is what we need. So the difference of these two will give us the answer. So it is 33.5 minus 27.7, which is equal to, in decimals, 5.8 units. So we get this as 5.8. Perfect. So our answer here is area of segment is approximately 5.8 units square. So in short, it is important to remember here that the area of segment is equal to area of sector take away area of triangle. So that is how you're going to find the area of segment. Perfect. So to find area of triangle, we need to find the altitude. So you could always use cosine of theta, right? So use trigonometry to find the angle. In our case, it was a special triangle, so we just got it straight. So we could say, we could find with cos theta, right? So anyway, so I hope you understand the whole concept. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Also watch part 2 and part 3 to get good understanding on radian measurements and some practice for your test. Thanks for watching and all the best.